Okay, let's get started. So in the last lesson, we spent most of our time understanding how to use the quadratic formula. And what I want to say is that there's different ways of using the quadratic formula. And if you are comfortable doing it in like 2 steps and getting the right answer every time, awesome. You just have to be getting the same answer as me every time. What I sometimes suggest is if students are getting the wrong answer a little bit too much, that a slightly safer option is to work out this delta thing first. Then once you find what delta is, take that and then work out your 2 answers, x equals something or x equals something. And what that normally looks like is just an extra step. Whether or not you use that, that's completely up to you. I'm not going to insist. Okay. The other important thing was things often to use the formula, you have to have the quadratic equation in the standard form. So you have to know what A, B, and C are. So as an example, if I said to you, here's your quadratic equation, that isn't in standard form. And if you used A as 3, B as 2, and C as -1, things would not go well for you. What you need to do is you need to move everything to one side. And now you can use 3 as A and B as -2 and C as 1. And then you can apply the quadratic formula. So we apply the quadratic formula to solve quadratic equations. It's not the only way of doing it, but it is probably the most reliable. But you do need to be able to factorize and do those types of things too. But for the most part, I'll use this. Give me a thumbs up if you understand everything and I can move on. Give me a thumbs down or ask a question if you want to clarify anything before we go. Okay. Cool. Then let's get rolling. Oh, let's go Natabaleng. Let's go to you. What's your question?
I wanted to please repeat the thing I didn't understand.
Okay. So basically, when we have, well, let's do the first example together, Natabaleng. I'm going to explain to you the topic for today is something called simultaneous equations. And within it, we are going to use the quadratic formula. So can I ask you to watch this example and then come back on the line afterwards to see if it helped? Okay. Okay, so let me explain, because there's 2 things going on. This is an equation, a simultaneous equation, and it's a little bit different to what we were doing last time, but it's going to include some of the skills we learned in the last lesson. So when in maths we say solve 2 equations simultaneously, what we mean is we're looking for a value of x and y, or if the equation was in a's and b's, a value for a and b that satisfies both of these equations at the same time. So say I made up some solutions and I said a solution to this equation is x is 1 and y is 3. That's a simultaneous solution. Am I telling the truth, or am I telling, or is it true? Or am I telling the truth, or am I telling a lie? Put in the chat whether you think I'm telling the truth, or do you think I'm telling a lie that x is 1 and y is 3 is a solution, a simultaneous solution to this simultaneous equation. Am I telling the truth or am I lying? How would we check? Well, if we look at this equation, a lot of you are saying it's true, but then it has to satisfy both these equations. So if I say x is 1, would you agree with me that 1 squared minus 2, what does that give you? Well, 1 squared minus 2 is going to give me -1. And I said that it has to, is 3 equal to -1? No, it's not. And so this cannot be a solution because it's not even a solution to one of these equations. It has to be a solution to both. Okay, so let's look at the second one. If I put a 3 here, and I put a 1 here. Oh, now I see why. Okay, so this is a solution to that equation, but it's not also a solution to that one. So I was a bit sneaky there. When we look for simultaneously, it means it must be a solution for both of these equations at the same time. Okay, give me a thumbs up if you understand why that basically it satisfies the one, but it doesn't satisfy the other. Okay, you understand. I love that I chose that example. It was such a good example because it showed you how you can get one right, but then if you don't get both, you haven't done simultaneously. Okay, so how do we actually solve this? Let me show you. And within this, we will get we'll get some practice with the quadratic equation. So step one is we look at the two equations and we normally label one of the equations 1 and one of the equations number 2. I will label the easier one, or the linear equation number 1. And I'm going to label this one over here equation number 2. And then what I'm going to do is I'm going to say, I want to sub equation 1 into equation 2 to eliminate one of the variables. What makes this simultaneous thing difficult is that there's too many variables, but if we could eliminate one of the variables, we could solve it. But equation 1 is looking a bit messy. And so I'm going to do some rearranging. I'm going to say that y is equal to 2x plus 1. Give me a thumbs up if you understand how I got y equals 2x plus 1. Okay. Now, this equation over here and this equation over here are the same equation, but I'm taking the one that is easier to deal with, and I'm going to sub it into the other one, which I'm going to call the pink one. And when I sub it in, I'm going to get 2x plus 1. That's going to replace this y over here. So I'm going to go 2x plus 1 is equal to x squared minus 2. So give me a thumbs up if you understand how I subbed the green one into the pink one, or equation 1 into equation 2. Okay. Here's the good news. We are now in the land of quadratic equations again, because this is an equation in one variable. Notice the y's have disappeared because I have substituted the one equation into the other. I want everybody to put this now into standard form. So Jonah, don't worry, this is the very first example. And so what we're going to do is we do example 1, and then I'll give you a chance to do it, a proper example by yourself after this. But for now, ask yourself, can you take the blue box and change that into standard form for a quadratic equation? Standard form should have a 0 on one side. So I guess the 2x and 1 have to move. So x squared minus 2, but then I'm going to have minus 2x and minus 1 because stuff moved across. And now my standard form is going to be, let's just make sure everything's gone well here. So that was 2x plus 1. Yes, 2x plus 1. It definitely becomes negative. And so I get that. So now this is what we call a quadratic equation in standard form, because you've got x squared minus 2x minus 3. Now, this is where that thing called the quadratic equation becomes useful. And so I want to go back to the very beginning of the lesson where I said I would show how this works. So we know that A is equal to 1, B is equal to minus 2, and C is equal to minus 3. We know that the quadratic equation, and you can write it in terms of delta, or you can write it straight in like that. You need to sub these values into that equation. You could do delta first and then do it, or you can do it all at once. But I want to see what answers you get if you try and get that. Well, in fact, let me do it with you. So minus b, so minus 2. This is where it gets a little bit crowded. But we can do it. Go minus 2, 1, minus 3, 1. And Paul, you can absolutely factorize. I'm just using the quadratic formula because I'm wanting to get some practice. But if you've spotted you can factorize, that's completely fine. So x is 2 plus minus. Now, I don't know what delta is. And this is where I get a bit worried about things going pear-shaped with calculators. But I'm pretty confident that delta is 12, 16. So we're not done yet, but we're close. So x is equal to 2 plus the square root of 4. So 2 plus 4 over 2. Or x is 2 minus 4 over 2. And for those who factorized, I see we're getting the same answer. We get x is 3 or x is minus 1. Oh, did I make a mistake? No, it did 12. No. So delta, there's a question if I made a mistake with delta. I'll show you I didn't make a mistake with delta because, watch this. Minus 2, 1, minus 3. This is going to be 4, and that's going to be 12, which is 16. Okay. Now we're not done. I would love somebody who maybe has seen this type of question before to tell me at the beginning, I said to you, you needed to find x and y, and yet I've only showed you x's. Would anybody like to tell me how I can find the y's? I'd really appreciate someone coming online and maybe helping me out. A Cat, can we unmute Cat?
Hi, sir.
Hey.
So I would have substituted x in equation 1
Okay.
for answers of x to get 2 answers of y.
So let me do that. So here's my equation 1, y equals 2 something plus 1. And you're saying put the x that you've got into that. So what did you get when x is 3?
I got, wait, hold on.
That's fine.
I got 7.
So did you get 7?
Yes.
Okay, because 2 times 3 is 6 plus 1 is 7. And so if x is 3, I'll put at the bottom here, y is 7. Let's do the next one as well. So it's the same equation. So that part's the same. But what's different is this is minus 1.
Yes.
What did you get for y the second time?
I got negative 1.
Completely agree with you. Okay. Now, these questions are worth 6 or 7 marks, but you can see it's a very definite process. And so the answers to this question are going to be x is 3, y is 7, or x is minus 1. Oh, I shouldn't say x down here. I should be saying y. Sorry. Or y is minus 1. And those are the simultaneous solutions to this quadratic simultaneous equation. Some other things I want to point out before I let you get going on a second example is that the pink one is a quadratic equation. It's got a power of 2, whereas the green one is a linear equation because it's just a straight line. However, in the end, you end up with solving a quadratic equation to figure out the solutions to this thing. So we had to basically solve this quadratic equation in yellow to get the answers for x that we were looking for. And then once we found x, we put the x's in into the other formula to find the y's. So Sipo, what we did is we took the x value that we found, which is 3, and we put it into the formula up here. And that's how we got 7. And then we did the same thing over here. So what I'm going to do is I'm going to carry on explaining to those students who are feeling a bit confused. But for those students who are feeling comfortable, I want you to try and start on this next example over here, which I'm going to leave at the bottom. And can you please start on that while I continue my conversation with some of the other students? So let's open it up for questions. So for those who are comfortable, I want you to find me the simultaneous solution to y equals 3x plus 7 and y equals 2x squared plus 8. And then I'm going to answer some questions. So who has questions to ask? Okay, well then, if there are no more questions, I'm going to let you get on to this next example and see if you can use the thinking that we used above. I will leave it in focus so you can kind of see the journey that we went on, if that helps you a bit. And yeah, if you're feeling confused, then just pop your hand up. Otherwise, I'm going to get a glass of water while you... Just let me know if you want to see the working above, but I was just thinking, let's make some space. If you get your x values, so the x values you think that are the solution to this quadratic, won't you put them in the chat just so we can compare answers with each other and we can see what's going on for you? My first step was to do that because equation 1 was actually very nicely set up so that I could sub it into equation 2 very easily. Yeah, let's go to Masana. Let's hear your question. Masana, can you hear me nice and clearly? Okay, we may be having a little bit of a audio issue there. Masana, we're trying to unmute if you can hear me. Okay, well then the second step was to put this in standard form, and that would be minus 3x minus 7 plus 8.
Hello.
Hi, how's it going?
Good, and you, sir?
Very good. How can I help?
Sir, I just joined the class and I'm late, so I'd like to know a brief of what has been happening.
Okay, so what I'm going to suggest is I'll give you a brief, but it's important that the recording that we did today and the previous lesson, you would be able to look at those because you'll get a better sense of what we were doing through the recording. So all we're doing so far is we're trying to solve these two equations simultaneously. And so we're trying to find solutions that X and Y that will satisfy both these equations. And step one was to substitute equation 1 into equation 2, which is this bit here. And then step 2 was to put it in standard form. And so students are now solving this quadratic equation, probably using the formula, and they're putting the answers in the chat of the X value they get for the one thing or the X value they get for the other. So what I'm going to do to speed things up a little bit is I am actually going to put the answers up, but I see a lot of students seem to be getting a half or 1. So let's see if they're correct. Okay, so they didn't use the formula in this case. They used factorization, but the formula will give you the same answer, and I'll show you that in a second. But you should be getting X is equal to 1, or X is equal to a half, and then the Y is 17 over 2 goes with that X, and Y is 10 goes with that one there. If you use the formula instead of factorization here, it would have just meant, so minus 3 plus minus, so B squared minus 4 times 2 times 1 over 2 times 2, which then gives you, that is going to be 8, that's going to be 9, so delta should be 1, so that should be over 4. And so then X is going to be equal to 3 plus 1 over 4, or X would be equal to 3 minus 1 over 4, which gives me 1, or it gives me a half for X, which is exactly the same as what they got here. And then the way to get Y is just to sub the value back into the original equation. So the original equation was Y equals 3, the easy one. So you actually have a choice. You could use either, but Y equals 3x plus 7, I'm going to use that. And I'm going to take my X is a 1 value. So let's use green. So X is 1. So 3 times 1 plus 7 is 10. So that's how I get this one down here. And then if I wanted to get the other one, I would go 3 times a half plus 7. And 3 times a half is just 1.5. So that's how you get 8.5, or 17 over 2, which is this one down here. So Naledi, substituting into equation, because we always choose equation 1 to be the simplest equation, it's normally always the case that you would go back to equation 1 to find the second variable. You don't always have to solve for X. Sometimes in some simultaneous equations, you'll solve for Y, and then you'll go and find X at the end. But that just depends on how the question is laid out, and we'll see different ones after our break. For Tejo, 17 over 2 can be written as 8.5 or 8.5. That's completely fine. Yeah. Fila, what's your question? Let's unmute you.
Hello, sir.
Okay.
So I was asking if we can write our values in coordinates form.
Okay.
Let's say.
So it depends on what the question says. Normally they say list it in coordinate form or intersection point, or give the intersection point, because this simultaneous solution is also the intersection point. So in this case, you'd normally write it as X equals Y equals. I don't think you would lose any marks if you wrote it as a half 17 over 2 and 110. If you did lose a mark, you'd lose 1 mark. But normally they say leave in coordinate form or give the intersection point. When they say solve for x and y simultaneously, they normally mean just leave it as x and y. So
Thank you.
pleasure. And so just to kind of give you a graphical picture of what's going on here, because I know this will come later in functions, but equation number 1 is a straight line. Okay, so this 3x plus 7 is basically a straight line that looks like that. 2x squared plus 8 is going to be a parabola that, what's going to happen? 2x squared plus 8 is it really going to be an 8? So it's happy 3x plus 7. Oh, yes, it's going to go like, I suppose it's going to go something like this. And that's why the x values, maybe I'm not doing it perfectly, but this second one is a parabola, and where they intersect, so where the straight line meets the parabola is where your solutions are going to be. But we'll talk more about that when we get to functions, but it's just, that's why we were talking about intersection points now. Those 2 points we found are intersection points. Okay, ladies and gentlemen, we have been working hard, and it's time for us to give our bodies a break. So what I want to see from every single person is I would love you to stand up with me and just give yourself a chance to unwind. Let's do the big circle, little circle thing. So let's just swing our arms. And just shake it out. Oh my goodness, my back is clicking like it's nobody's business, but such is
mine too.
Yeah, you can hear it. It's funny, huh? Because we've been sitting.
This
Now,
actually feels good.
it does. And that's why you may think I'm silly, but I will persist with this because I know it's helping you, even if it irritates you. So the next thing I want to do is, because we know that raising our heart rate a bit and getting the endorphins going is good for us, we are going to do 10 jumping jacks. 10 jumping jacks. Now make sure nobody's near you, because your elbows might cause problems for them. And I don't want to have bloody noses and things like that. But what we're going to do is a jumping jack goes like this, so up, and your feet, so you go 1, 2, and then we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9.
Guys, don't do them sitting down. I can see.
Oh, do them sitting down. Whew. You must be a little bit out of breath. That is the key.
Yeah, I still computer they're doing it sitting down. I see
Yeah,
you guys.
This doesn't count, eh? This is like a chance. This is not a it's not a jumping jack. Okay. Now I really encourage you. You may think I'm a crazy person on the internet, but I know that it helps you to focus and to let your body unwind. It's stressful sitting for half an hour. It's even more stressful trying to absorb something new. So there is some thinking to my madness. Okay, let's do a little brain break. So we've done the stretch. What I want is I want you to try and make 24 using, oh, I'm out of breath still. Make 24 using these 4 numbers. You have to use each number once, and you can only use plus, minus, times, divide, or brackets. See if you can get to 24 using those 4 numbers. So how do you get to 24 using these? This is a game called Maths 24 that is quite a nice thing to play in class sometimes if you have a bit of free time and you just want to work on your basically your numerical skills, I guess.
Yeah, Petra was freaking out. She's like, what is this?
Simtanda knows this game. So you have to use each number once. And okay, Nasha Beleng, you're almost there, but you've only, oh wait, how did you go? Tell me how you got 6 and how you got 4. And then I think you are the winner of the first round of this. So 6 times 4 is 24, but how did you get 6 and how did you get 4? Letty says 4 times 1. You used your calculator. So 4 times 1 is 4, and 7 minus 1 is 6. And so then 6 times 4 is 24. Yes, because that uses those two, that uses those two, and then you've got 24. Very nicely done. Let's try one more. This is a slightly harder one. It's a 2-dot card. See if you can do the blue one. Can you make 24 using the blue card? So for Tejo, we're trying to use the 4 numbers, 7, 4, 2, and 2, to make 24, but we can only use those 4 numbers and we can only use the normal operations. Okay, so there's a couple of tips coming in. And Paul says, ain't no way. You never know, Paul. Things can... 7 times 2. So, well, I was thinking with maths 24, the factors of 24 are 12 and 2, and 8 and 3, and 6 and 4. So those are normally helpful numbers to get to if you can. So how about 7 times 4 minus 4? I think you may have it for Tejo. So can anybody see what I can see? Oh, yes, you have definitely seen it. Okay, so 7 times 4 is 28. And then you can go 28 minus 2 minus 2, and you get 24. And I see lots of people have got it. So Emmanuel, Vasedi, Lawandla, Kwazile, and many more of you. Okay, cool. So just give me a quick feel. Did you enjoy the Maths 24? Was it something nice? I just felt like something different. It's weird. It is a bit weird the first time you see it, but it's strangely addictive. So hang in there. I suspect it may be back. Last one, please. Definitely. I love the diversity in the class.
Yes.
Okay, let's get back to our main mission for tonight. Now, our main mission for tonight is to get better at solving quadratic or simultaneous equations, and often there's a quadratic hidden inside them. So let's go to something that looks a little bit different. Here are 2. It says, given the functions y equals 6 over x and y equals x minus 1, find the coordinates of the points of intersection of the 2 graphs algebraically. Now, there's a lot of words that are thrown in here, but basically what they're saying is find me the simultaneous solutions of y equals 6 divided by x and y equals x minus 1. Now, before we start, bonus points for naming what type of equation or what type of function the green function is and what type of function the pink function is. If you want to come online, you can tell me, otherwise pop it in the chat. Do we have any volunteers? Do you think they can identify the pink or the green 1. Okay, let's go to Netebocheng. What do you think each one is?
Hi, sir.
Hey,
I think that the green one is hyperbola and the pink one is a straight line graph. I think.
you are correct. Well done. So, thank you very much. It is indeed a hyperbola in a straight line. And so you need to think about the last question we did and try and use what you, so I want you to try and do this by yourself. I'm not going to give too many hints, and tell me what you get for your first set of like rights or answers. If you're stuck, I want you to raise your hand and we can unmute and have a chat, but see if you can figure it out by yourself. How would you start this process? What can you use for the last question? And which one would you call equation 1 and which one would you call equation 2? the comments, it's an interesting one. Yep, you're doing it by yourself. Okay, so I would suggest we call this equation 1 because it's a straight line, and this is equation 2. Is it possible that we can eliminate one of the variables by subbing equation 1 into equation 2? I think it is. I think there's a y over here and there's a y over here. And so we can just go x minus 1 is equal to 6 divided by x. Now, that is an equation with fractions in it, but it is still an equation which only has one type of variable. So step 1, we call this substitution. We sub the pink one into the green one. So I want to ask, can you take this equation now and get it into standard form? That's the next step. Maybe someone can come online and suggest, how do we deal? It feels to me like this x over here is the problem difficult part. Does anybody have a way of, it's almost like it's gone underground. Can we do something about that? Let's go to Rafense.
Hi, Mr. X.
Hi.
How are
Have you got a suggestion for us? Very good.
Yeah, I think we must just multiply all the terms by the LCD, and since X is the only denominator, it means that it's the LCD, so we'll have to multiply everything by X.
Perfect. Love it. So everything gets multiplied by X, because if you do that, it'll knock out this X here. So you should then get X squared minus X equals 6. And then you can write that like this. This is now in standard form. Now, to be honest with you, most of the time I would use the formula, but in this case, it feels like it could factorize quite easily and quickly. And so it's not wrong to factorize this trinomial, because if you get it in that form, some 2 brackets equals 0, it's probably even quicker. So I leave it to your discretion, but what do you get for the 2 x values? X equals or X equals? Alyssa, let's go to you. Can you hear me? Maybe we have a bit of problem there. So if we factorize this using the cross method that I showed in lesson, I think it was lesson 1 and lesson 2, or we can use the formula, we'll get the same answer. So minus 3. So we should get that x is 3 or x is minus 2. Both using the formula or using this method. Now, I want you to figure out for me, what are the y values that go with the x values? That's your next challenge. Yep,
Mr.
it's
East?
all about, yeah.
We have a hand from Masana.
Okay, let's go to Masana. Masana, what's your question?
Sir, before you continue, I still don't understand how you got the x minus 1 equals 6 over x.
Okay, that's what's called the substitution step. And I'm basically, can you see that both equations have y's?
Yes, sir.
And so what we can do is we can equate these by saying, look, if y equals 6 over x, then these two y's are the same. So where there's a y now, I'm going to replace it with x minus 1.
Yes,
And
sir.
so that
Oh,
eliminates one of the variables. And so now I only have to solve an equation in one variable, which is a lot better than having two.
okay, sir. Thank you, sir.
Does that sort of make, see if we're going to do another example after this. So see if you watch the process as we go.
Yes.
Okay. So for y, I was thinking we should just use equation 1. And if we do that, y equals something minus 1. If the something is 3, then y should be 2. So that gives me y is 2. And if y equals something minus 1 again, but that something is different this time, it's minus, what was it again? Minus 2. Then this should be minus 3. So y is minus 3. And so up here, I'm doing my subbing in, and I'm using equation 1. Yeah, let's go to Fatejo. What's your question, Fatejo?
Hello, sir.
Hey,
Sir, so can you do this using the quadratic formula?
I can. So the step that we're going to use is we're going to go from this step over here. Okay, so I'm going to go through that now with you. Before I start though, those students who are feeling comfortable, I would like you to try another one while I am busy with this. So here is your next simultaneous equation. I want you to try and solve that one at the bottom while I do the x squared minus x minus 6. Okay, so let's do this. If we are using the formula for this one, we need to know what A, B, and C are. So A is going to be 1, B is going to be minus 1, and C is going to be minus 6. Then I need to know what my formula is. Now, this is always given to you on the formula sheet or on your test paper. So I've got that. Now I need to plug values in. So I've got minus B, but minus 1 is just 1. And then on the bottom, I have 2 times 1, which is just 2. And so this thing inside is delta. And I can do it in my head, or I could do it separately. Maybe I should do it separately. Make some space. Let me get rid of this. You could do it in your calculator too. So delta is B squared minus 4 times A times C. So that's minus 1, 1 minus 6. So that's 1, that's 24, 25. So x would be equal to 1 plus the square root of 25 over 2, so 1 plus 5 over 2, or x is 1 minus 5 over 2. And so x would be 3, or x would be minus 4 over 2, or minus 2. Which, good news for me, is the same answer using whatever method we did before. And to find y after that, we just simply go back to the y value. We basically use equation 1. Okay, was that helpful? I hope so. But we got the same answer. That was the main thing. Now, for those who are working on the next example, what you notice is that it's a little bit more messy, but I still think I can see that I would call this one over here equation 1 and this one over here equation 2. Pleasure, Fatejo. I'm glad it helped. So when we start this journey now, I want us to think about what do we need to do to equation 1 before we can, well, how do we make our lives easier? You know, everybody wants to make their life easier. You don't want to like make it more difficult than it needs to be. Life is already difficult enough often. So can somebody maybe give me a hint in the chat? What do I need to do with equation 1 to make my life easy? Or Fila, I see that your hand is up. Can you help me out? What's a good tip?
We can make y the subject of the formula.
Yo, absolutely. That makes a big difference. What do you get for y from looking at this?
Oh, so our y will be equals to negative 2x plus 2.
Brilliant. Exactly. And so that's the one. We're going to sub that into equation 2. Because equation 2 looks difficult though, what I'm going to do is I'm actually going to take some insurance and I am going to leave a space wherever I need to sub in, because it gets a bit harder to keep track. So what I'm going to do is in equation 2, wherever I know something has to go, I want to leave a space, a bracket that reminds me. And then once I've done that, I can take the y that I'm subbing in. Oh, I've left something out. Look at that. Goodness gracious. Can you spot what I've left out? I've left out the square there. And so then we go minus 2x plus 2. And here there's also going to be a minus 2x plus 2. Now, what makes this question a bit harder is that we have something, or we're squaring a binomial, or there's basically minus 2x plus 2 is regarded as two terms, and we have to square that. I want to see, can you get this whole rather messy looking thing into standard form for me? That's the step that I'm really interested in. Can you get this whole thing here into standard form? If you're feeling a bit confused, you can raise your hand and we can chat. But that's what I want you to see if you can do. Yeah, you need to square it. Some of you might know a shortcut. Some of you might just want to write this out the long way. And then I'm going to move the x to the front. So there's quite a lot of action going on here. We need to be careful we don't make a silly mistake. So let's see what we get to. Once you've got your standard form equation, just let me know in the chat. I want to see if we're all getting similar things. We have 2x squared plus 4x squared plus 6x squared. So I'm doing all these ones first. And then minus 4x minus 4x minus 6x plus 4. I get 8. No, not even 8. I get 12x squared minus 8 minus 14x plus 4. And that's what I get. Okay, now, that was quite there's lots of places that could go wrong. Now, I want to just suggest, if you've only made one mistake so far, even if you've got the wrong equation, if you've only made one mistake, your teacher will carry on marking, hey? So don't worry if things go a bit pear-shaped. You can afford to make one mistake and we will carry on marking. You'll get partial marks. Yeah, I feel that this is a bit trickier. And so this is the difference between, say, like a foundation and standard lesson, is that we go a bit further in terms of what we show you. But yeah, that is the main difference between the two courses. So let's try and get our x values. What x equals what and x equals what? Okay, so Alia, look at where maybe we were different, because I think what happened was you didn't get a plus 4x squared here. That might have been your problem there. Okay. Yeah, so basically what you have here is your minus 4x minus 6x gets you to minus 14x. So let's see if we can get our answer. And this is where the formula is quite nice, because you go a is 12, b is minus 14, c is 4, and you go minus b, so it's 14, whatever delta is, over 2 times 12. What is delta? It's gonna be, I might need a calculator to help me here. Minus 4 times 12 times 4. Who wants to tell me what delta is? So b squared minus 14 squared minus 4 times 12 times 4. What do you guys get for delta? Who's going to help me out? Is delta 4? It looks like that could be right. 16 times 12. Yeah. Okay, awesome. So then 14 plus or minus delta over 24. And so then x will be equal to 14 plus 2. So 16 over 24, which is 2/3. I'm going a little bit quicker now because we are running out of time. Or delta is equal to 10 over 24. Wait, no, 14 minus 2 is 12. 12 over 24, which is a half. So we should get an x value of 2/3, or x is a half. Can you get me my y values to finish off today? And my tip to you is to use the green equation. The green one that I've highlighted green, I think could be very helpful. So we know that we're going to use this calculation. What do we get for that?
Mr. S, are you able to take a question?
Yeah, Loyolo, let's go to you. Is that, yeah?
So,
Hey, what can I help you with?
so where it says 2x squared plus 4x squared minus 4x minus
Yep.
4x plus 4. Isn't
Yeah.
minus 4x minus isn't negative 4x minus negative 4x equal to negative 8x?
It is, yes, absolutely right. So if you look at that part by itself, that is, maybe that's a bit dark. Let me undo that for a second. So if you look at just that part by itself, it is negative 8x. The problem is there's a 6x sitting over here. And when that comes across, it becomes negative 6x. Are you with me?
Yes, sir.
Perfect. So what have we got for those y values? It seems like we are getting 2/3. Let's see if I agree with you. 2/3 and 1, 2/3 and 1. So minus 4/3 plus 2. 2 would be 6/3. So we would get, yeah, we get 2/3. And the other one, when x is a half, minus 2 times a half is -1 plus 2 is 1. So y would be 1. So 2/3, 2/3, or x is a half and y is 1 would be the solution. Yeah, it'll be a lot of marks. Don't worry for Deco. No, but listen, we've only had one lesson on this. Like in class, normally you do a lot more. So the idea is not that I make you simultaneous equation geniuses, is that we lay a good basic structure in your head that you can then go and practice.